Assalamu alaikum, I'm back with applicationsecurity.io and today we are going to do the SQL injection room. So let's start this lab. So Invoiceable is a website that we are going to pen test. Alice is the city of this website and he wants Bob to pen test this website. So let's move further. So this is the URL of invoiceable.com. Let's enter over here and see what do we get. So here we have a login form with email and password, but before entering the right username and password, let's look at the view page source area where we can look at the HTML of this document. So let's analyze this code. So here we are presented with the login form in which we have two fields which are username, input field username and input field password, and there is a button for the submission. Let's click back here. What is the next thing? So the login form further defines the username and password input field as I told you. The next thing is finally a submit event handler is declared. So whenever the user will click the submit button, event handler would take the charge and submit the request to the API endpoint. Login is the name of that function which is present over here. On click submit, the login would be called. Let's come back to the login. Here it will send the external request to retrieve the IP address. Then it will create an request for api.invoiceable.com/login. The method would be post. The content type would be the JSON and the JSON stringify function to be used to convert the JSON file to the string, and whatever will enter in username password fields in the top would be added over here. And now the new JSON is created and it is ready to send to the server at this API. What's the next thing? So here I told you that these are the field value that would be obtained from username and password input fields. Move further. So let's enter the email and let's enter the password. Click on the login and let's see what is present in this HTTP request. Let's analyze our code. Now as we have seen that the post request is sent to the login endpoint and the username field is filled with bob@livemail.com and password field is filled with password123. Let's move further. Next, a password parameter password is sent along with the Bob's password. Okay, and we noticed that there is an IP address also present in this request that we are making to this API endpoint, API/login. Let's move further. So before we continue testing the Invoiceable application, let's further analyze how Bob's HTTP post request is handled by Invoiceable application to authenticate user. Now this is the code of this API endpoint to see how it is actually performing the authentication by using the login credential we have presented. So Invoiceable developers have implemented the login method to handle the user login process. Okay, this is the method which is responsible for validating the user. The login method is expecting username, password and IP address parameters to be provided by the post request. Okay, so username and password is validated using this validate credentials method. Let's move further. Now here you can see that there is an SQL statement created with the IP address to see that if this IP address area is in the whitelist of the website, that the people from this region can access the website or not. So this is an SQL query made using the IP address value sent by the client. Move further. To check this, a dynamic SQL statement is constructed by concatenating the IP address variable with a predefined query. All the query has been written already, and whatever you will send in the IP address will be plugged in here, and then the SQL query would be executed using this execute query statement.execute query method. Okay, let's move further. If such IP was found, the authentication session is set and the retrieved user ID variable is returned by the HTTP response. If all the things match, then the user is allowed to log in. Okay, let's move further. We know that this SQL statement that we have seen is may prone to attack or compromise. Let's add one more apostrophe here, and we know that you can see here whatever I'll change the IP address here. It would be shown over here to show you that how this statement would actually get created. So this is the IP address, for example, that we are going to send the server. In this format, the SQL query is work totally fine. But what if we add this apostrophe here or here? Now we have two inverted commas or apostrophe, whatever you say it. So it would generate an error on server side and error would get reflected on our side. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL version. So we have received with an error. So let's analyze the code. Following the modification of Bob's IP address with a simple quote, the IP address string is directly concatenated over here and input validation checks against the IP address variable. Let's move further. However, since the Bob's IP contains this character, the additional trailing code is now unbalanced, okay, resulting in generating an SQL error. Let's move further. So this would ultimately generate an SQL injection attack. Let's move further. So interestingly, reviewing Bob's HTTP proxy response, we can see that the JSON response object return a SQL error syntax as we have seen here when we have analyzed the code. Let's move further. So in the previous step, Bob was able to inject a single quote by the IP address parameter, confirming that the invoiceable application is vulnerable to SQL injection vulnerability. However, it is important to note that nowadays modern web applications do not generate SQL error message on client side, and on the client side, if someone is trying to attempt SQL injection, it is not possible for him to feel that what is happening on the server side. So how can attackers like Bob exploit SQL injection when verbose SQL errors, when there is no errors generated on client side? Okay, so there are some tools, and very common is SQL map, which can do these things automatically. Let's download this tool here. For downloading, you can refer to this GitHub repository, and then you can change your directory to SQL map/dev. Now we have installed an open source pen testing tool that automates the process of detecting and exploiting SQL injection flaws over the database server that are vulnerable to SQL injection vulnerabilities. Let's move further. Now you'll have to run this Python SQL map tool on this URL, and you want to change this parameter IP address, okay, and the method that you want to use to send to server is the post. Let's press enter, and let's see what has happened by this SQL map application. Upon executing SQL map, first it displayed the warning banner that you must have explicit permission to run SQL map on the target machine. This is the disclaimer from them. And then there is a payload IP address equal to 1 and sleep equal to 5. If you are aware of time-based SQL injection, you know that it is a difficult thing to do by manually. It's the first thing. And the SQL map tried to go for the sleep variable to check after how much time the response is returned back to SQL map, and thus in this form it had enumerated the databases, the tables, and the SQL map tool inject the SQL function sleep5 by the IP address parameter, which forced the database to wait for a specified amount of time before responding. By injecting the sleep method, an HTTP response will be returned with a delay or returned immediately, allowing SQL map to infer if the injected query returned true or false, even though the backend database is configured to not respond to SQL errors. Okay. By using the sleep function, SQL map can rapidly enumerate and brute force remote databases, including databases names, tables, and other sensitive data. We can see that SQL map has successfully identified the database name invoiceable master, and then it has also extracted the table names, several table names, and which can further enumerate to leak sensitive data and password hashes. Okay, let's move further. So let's analyze this code again. To recap, the login method extracts the username, password, and IP address from the pass request body. Okay, and then those usernames are validated against if they are correct or not. Then IP address is checked that it is from the region that is on allowed list of the website to see the content, but there is no input validation placed over here. All the characters, symbol, digits are welcomed in this query, which was an not to do thing. So let's move further. How we are going to mitigate this? We are going to use the parameterized queries, in which this place is filled with the question mark where the IP address would be placed. Okay, let's analyze the code again. And this is actually a pre-compiled query. We then build a prepared statement, which pre-compiles a string SQL into prepared statement object. The query will be compiled before receiving the IP statement, and whatever the IP address would be sent by the user, then this function would be used to fill this pre-compiled SQL query with the parameters, and it is able to escape all the characters from the IP address area. So the setString method automatically escapes special characters such as quote by treating the input as single string literal and not as a part of SQL query, thereby ensuring that raw SQL queries cannot be injected via external parameters. So this is all from this SQL injection lab. We'll meet in the next thing. Jazakumullahu khair. Allah Hafiz.